speaker today is Mike Goodman. Mike is a recognized leader in the field of system dynamics and systems thinking, whose primary interest is in developing and applying systems thinking to organizational change and learning and enhancing organizational capacity through development of the learning disciplines. Mike holds a BS from Purdue University and 2 master's degrees from MIT in mechanical engineering and management, where he wrote his thesis, Elementary System Dynamic Structures, under the mentorship of Jay W Forrester. Since then, Mike has spent 40 plus years delivering systems thinking curriculum, teaching and training in organizational learning and change, and helping both corporate and nonprofit clients tackle all kinds of industrial, organizational, and social issues. He's also helped create many of the innovations in the field of systems thinking, including being one of the original developers of the systems archetypes, which helped unleash the power of thinking systemically to the world. He has published widely, authoring one of the first textbooks in the field, Study Notes in System Dynamics, and serving as the primary contributor, or a primary contributor, to the systems thinking section in the acclaimed Fifth Discipline Fieldbook by Peter Senge, and other chapters in the follow-up field books, The Dance of Change and Schools That Learn. He contributed to the recently published Systems Thinking for Social Change by David Stroh, and has also published a variety of articles on systems thinking and system dynamics in areas from culture to healthcare. A principal at Innovation Associates Organizational Learning, Mike now leads applied systems thinking in collaboration with David Stroh. And I've shared the pictures here because I've had the pleasure of personally knowing Mike and working through our systems lectureship that we do here at Texas A&M University, Kingsville. And so I pulled some archival photographs of Mike teaching there. So again, Mike, thank you so much for joining us today, and we're thrilled to have you and to learn from your experience. Let me take.
Yeah, let's take us off sharing so we can see people. So thank you, Ben, for inviting me here. Thank you, Ben, for being a wonderful student. We go back now. When did you take the initial workshop?
The first opportunity to do that with you was in 2009.
Yeah, so that's already like 12 years ago. So I've been teaching at the King Ranch Institute. I don't know if you want to say a little bit about the King Ranch Institute program, particularly the.
Sure, yeah. So our program here is, as many of our regulars will kind of know, our King Ranch Institute program. It kind of has the foundation of it is in systems thinking. And since really the inception, Mike's been coming down and teaching that as sort of the first foundation experience that the students in that program get. And so I had the pleasure of doing that in 2009, yeah, as was stated. Yeah. So let's go ahead and jump in here, Mike.
Sure.
So for the audience, we have some prepared questions, and then we've saved enough time for some open Q&A after that for anything that comes to mind. So Mike, I'm assuming your first exposure to systems was when you were a university student. Do you remember what that was, and what was it about systems that really drew you in?
Yeah, so Ben, one thing I'd like to do, because I think you guys all know each other, may know each other, but maybe we could just go real quick I'm glad to answer the question. Maybe we could just have people quickly introduce themselves and say where they're from, where they're at. Is that okay? Will that throw you off too much?
Sure. If we just round robin, Andres.
Yep.
Yeah, sure. So I'm Andres. I'm a PhD student at the Swedish University of Agriculture. Well, I've been doing system dynamics for a couple of years now, working a lot with water resource management.
Great.
And Hector?
So I'm Hector Menendez. Mike, I took your lectureship and 2-day lectureship in South Dakota in 2015, and have really been indirectly impacted through Ben. So I'm grateful for all your effort with the King Ranch.
Yeah, you do look familiar. Thank you.
Yeah, I'm a professor now, or assistant professor in Rapid City, doing livestock grazing systems and applying systems.
Awesome.
Mm-hmm.
Awesome.
Julius?
Queensland.
I think you're muted. Julius, I think you're muted.
Yeah, you are muted.
Yeah, can you hear me now?
Yeah.
Yep.
Yeah. My name is Julius. I'm currently a postdoc fellow with the University of Queensland, and I started applying systems thinking and system dynamic in my PhD project here in the University of Queensland in 2014. And since then, I've been using it, applying it more in water resources, agriculture, specifically value chain, and currently I'm working to apply it in supply chain management in the grains industry in Australia.
Great.
Berto?
Thanks, Ben. I'm Alberto Azzori. I'm senior researcher of the University of Italy. I started with system dynamics in 2011 at Texas A&M, and I had the opportunity also to collaborate with Ben and Hector. And I'm applying system dynamics to animal science and agriculture in general.
Kelechi left his information in the chat that he can't talk now, but Kelechi's from Nigeria. I'm not sure if Anna, Lily, or Beverly would like to introduce themselves.
I'm Lynn McFadden. I am actually one of Hector's students in South Dakota, working on my master's in ruminant nutrition.
Oh, cool. Great.
I'm Anna Daigle. I am also in Rapid City, South Dakota, working with Hector Menendez on my master's in animal science with ruminant nutrition as well.
Awesome. That got it?
Maybe, yes, please, Beverly. Raise your hand and then.
She's muted. Okay, well, we can
Sure.
go forward.
Well, Hector, if you add any more, you'll need your own SIG.
I know, I was gonna say, this is Hector Sig with.
So,
congratulations.
so those are some round robin introductions, Mike.
Okay.
So I'll just repeat the question because we had some folks come on here. So I'm assuming your first exposure to systems was as a student. Do you remember what that was and what about systems really drew you in?
Sure. So I was trained as a mechanical engineer at Purdue, and I decided after that, I was a co-op student working, every other semester. And I decided after that engineering, I'm not quite sure was going to be all that exciting for me, kind of getting down at the macro level. I was kind of more interested in how things were connected. And there was a program at MIT in the grad school that sort of combined engineering with the social sciences. So I applied to MIT, arrived there, and really was struggling to find my place. And my thesis advisor, I think my second term, directed me to go to a lecture to hear this guy named Jay W Forrester at the Sloan School. And I literally did that, sat next to Peter Senge, who you've mentioned, and kind of the rest is history. I went, whoa. What I loved was that there was this sort of technical, quantitative side, but also the big idea side. And so all this was new to me. The idea of feedback loops, which I had been exposed to as an engineer, but never put together in terms of how that might work in human systems. The idea of simulation at that time, you were still using punch cards to run models. And there was a thing called Dynamo, which was the language before all the current languages we have, which is pretty primitive, one step above Fortran. The idea of modeling, the idea of addressing human and management issues and not just technical stuff. So that's what drew me in.
Awesome. So you mentioned Jay Forrester, and I think if my timeline is right, you were around MIT when some of the most visible system dynamics work was being done in his group. And this sort of bombshell one that comes to mind is world dynamics. But there's a lot of other important work going on around that same time. And I wonder if you could kind of take us back and maybe share with us that time in the field. And besides that, the other impactful work that you were a part of and also witnessed, and the impact that's left on the field, even for us today.
Yeah, well, I mean, who knew at the time all that stuff was happening? So yeah, so I joined, I think in the second semester there, I started taking all the system dynamics courses that were offered. Jay was teaching some. There was a guy named Greg, I can't remember his first name, who he had a couple of people teaching stuff. And at the same time, the Meadows were there. Jay had just finished urban dynamics and I think was in the process of doing world dynamics. So all of these things, I'm assuming people are somewhat familiar with that, were just coming out at the time. This is the early 70s. And it was a pretty exciting time. Urban dynamics, I think, was getting all sorts of reviews, some very, very positive and some very, very negative, particularly from the economists at the time, econometrics guy, were saying, well, I don't know, these models, they're high level, they're not, how do you prove this is right? How do you validate this stuff? And they completely didn't get anything about the nature of the models, which are quite different than your classic econometric kinds of model, which are data driven, very different as we know. But the idea of feedback and long-term and all the stuff that's built into a system dynamics model was just really alien, particularly at that time. What I find striking, and if anybody ever says, how do you ever validate the system dynamics stuff? If you look back at that work, urban dynamics, and the other one that you mentioned, world dynamics, which are all back in the 70s, late 60s and 70s, and you look back how true or accurate were they, you'll be amazed. Jay complained with urban dynamics that the war on poverty, which is a big push for low-cost housing to revitalize the core cities, that was the big LBJ war on poverty, that was the wrong thing to do in the long run. And all you would do is concentrate underemployed and minority groups and unskilled people in the inner city. You would erode the tax base. You would drive out businesses and all these consequences, which, by the way, have all proven absolutely true. Same with world dynamics. Can we continue to grow at the way we were growing? And we know, and there's fortunately been the limits to growth books and a lot of research that's backed it up. And here again, even that little simple world dynamics model, very high level, and the subsequent work on limits to growth, pretty accurate. So yeah, we were all like tearing our hair out, like, okay, well, how do we address those validation issues? Well, the reality is you can't ultimately until you let it play out over time.
Right.
Yeah. So I think I answered the question. I'm not sure, but let me know.
Sure. And one thing that I mentioned in your intro, Mike, is one of the early contributions that you made to the field was your book, Study Notes and System Dynamics. And I once had the great blessing to hear you share impromptu the background of how that book actually came about and the work that you put into it. And it's a really neat story that I don't want that I think others to capture would be great, because just to hear the background of that story and how it came about. So I'm wondering if you might share the story of the genesis of your book.
Yeah, not my finest hour, but how many people are familiar even with that book, which was published 1974, I think, called Study Notes in System Dynamics? Raise your hand if you've ever seen it, read it, or heard it, other than Ben. Yeah. Ah, one. I got one. Yay. Okay. Nobody else. Okay, that's good. I think it's still being published. I think the System Dynamics Society now has it. So here's the story. Up through about 1973, 74, Jay Forrester was the only person who actually ever published anything in system dynamics as we know it. He had principles of systems, industrial dynamics. Interest was starting to grow. As part of my thesis, I decided to focus on building kind of librarying and then building simple models that were core to urban dynamics and world dynamics and some of the other stuff that industrial dynamic, try to capture those core structures that we now know as the archetypes, like limits to growth. And that was my thesis. In fact, I was looking specifically at the core. How does limits to growth? How does a system work that creates a limits to growth? How does that S-shaped growth get created? What's the basic core stock and flow that produces that? And then everything else is a complex version of that. Anyway, wrote my thesis, and I think in a random conversation as I was handing it in, and I think Jay had given me some feedback, Jay suggested, well, you know what, this is cool stuff. Maybe you should think about writing a book. And I said, yeah, that sounds like a good idea. So I think this is around Thanksgiving, before I was supposed to graduate in the following May. I was at the Sloan School of Management. I had finished my engineering degree, so I was going for that second degree. And I think Jay called me into his office, says, I haven't seen the manuscript for the book yet. I said, book? What book? He says, I thought you were going to write a book on simple structures. That I said, oh, that book. Oh, okay, gotcha. So I then spent the next 2 months intensively skipping, Christmas and everything else, staying on campus at MIT, and taking my thesis and adding a lot more stuff and getting some help from some of my peers at the time, and put together the first draft of study notes. And he then had, at that time, because nobody else would publish this stuff at that time in academia, so Jay had his own publishing company called Wright Allen Press. So he hired the editor to sort of work my manuscript and turn it into a book. I wasn't a very good writer at the time, probably still not very good writer, but I remember the editor, who was actually turned out to be a great friend, at one point, as he was reading through the manuscript, asked me if English was my native language. It was so bad. Later, another editor who picked it up said, someone should have broken all of your fingers when you were young, because you're writing. Anyway, I learned a lot from that process. That's how the book came about, literally. Put it together in a couple of months, intense, lonely time putting it together, and off it went. And it was the first non-Jay Forrester system dynamics book, I believe, at the time. There might have been some case studies that had been written, but that was it.
Sure. And I'm not in my office, but I have my copy of that, the updated version that the society publishes. I haven't translated all the same models, but having gone through there, the content, Mike, is you might remember your writing at that time, but I can tell you still the theory and the concepts and all that are still relevant and useful. So we certainly appreciate that contribution even today.
Thanks, Ben.
So after your graduate programs, and of course I'm biased because I've known you these years, Mike, but you've had as influential as career as anyone I can think of spreading the message of systems thinking and equipping people to use the tools in the systems thinking toolbox. So are there maybe one or two career highlights where you would say you significantly impacted an organization or management or something insightful for a client that you would be able to share with us, and then what insights you might have taken from that that would be useful for us as we try to increase our impact as well.
Yeah, well, thank you, Ben, and thanks for that kind, generous introduction. So, yes, and I even have some stuff I pulled together here. So, let me start by saying one of the things. So, right after MIT, I joined the then only a dedicated consulting firm in the world that was doing system dynamics modeling. That was called Pew Roberts Associates. So Jack Pew, who was the developer of the first system dynamics language called Dynamo I mentioned, and Ed Roberts, who is still at MIT to this day. Both were students of Jay Forrester, I think. Both were students of Jay Forrester, and Ed is quite famous as not only his early work in system dynamics, but all his stuff since on entrepreneurship and startups, and quite well known in the field. Anyway, I joined a firm that they had created right in Cambridge, a spinoff at the time from all the MIT, among the many MIT spinoffs. And spent years building very detailed, complex system dynamics models. At one time, we probably had the largest simulation model in the world. Then we were still using punch cards, so you had to run it overnight on an IBM 370, the big mainframe computers that took buildings. So I remember spending many nights running this thing, and you get one card out of place and the whole thing would collapse. So you had to redo it and wait another 24 hours to get it run. Can you imagine doing that today? Anyway, but after years of doing that level of complex modeling and realizing it wasn't having much impact on decision-making and policy, that the people who were learning the most about the system were the modelers, not the clients, not the beneficiaries of this work. And so I took this to heart and said, I want to have more direct influence. I want to be able to connect system dynamics and the insights and the power of all that to people that would be available and accessible to them, and that going through building these large complex models was not my thing. And frankly, I wasn't very good at it anyway. I like simple and easier. So I began to shift my focus from hardcore detailed dynamic modeling to softer qualitative, like what are the lessons we can take from all of that great work and put it into a larger audience, put it into the hands of a larger group who will never probably ever deal with a model or certainly ever build one. So that sort of shifted my focus. So that's where the system archetypes eventually came from, even from my first book, Study Notes. And some of those ideas, that's where the iceberg came from that I think many of you are familiar with. A lot of those simple frameworks were basically drawn right out of the more detailed quantitative system dynamics work. So back to your question, Ben, let me bring up a couple of examples here of things that were particularly notable for me in my career. This all caused me to kind of have to reflect on, okay, wait a minute, did I do that right? You can still see me? Hold on here.
We see you and we see your screen.
Yeah, my busy screen. Let me get the right, there it is. Okay, how's this? You see still seeing my screen? You see these slides?
Yep.
And go on. Okay, so let me get to the top of this. I don't know where I am. I love it when it starts. Okay, so in more or less order, there are a couple of three examples. I may only have time for two of things that were, for me, turning points or aha moments that led me to believe that what I was doing, and I was a bit different than the mainstream. Most of the people I went to MIT with stayed on, got their PhDs. A lot of them are names you'll know. John Sturman came in later, but people like Peter Senge and John Moorcroft, and we were all doing this stuff together back in the day. But they pretty much stayed pretty close to the system dynamics modeling part. George Richardson a little bit later, but as I was kind of going off doing the more qualitative side versus the quantitative side, I never really abandoned the quantitative side, but primarily moved to the qualitative side. So one case that I love to talk about that I hopefully can do very quickly was a client out in the San Francisco area called Mentor Graphics. I think they're still around. And they are a software manufacturing company, actually, that provides software to people, to engineers who design systems. So it's not customers like people like you and I, it's customers like companies like Motorola and IBM and Intel at the time. And they were pretty large companies, and they requested some help. And they were puzzled by the fact that they had new products, basically new software products that they were launching, and they weren't being purchased as fast as they thought, and it was taking much longer. And so that what they had a parameter called time to volume, like the time from the date of launch to the time they met their volume target for how many people would be subscribers to the software, was way much longer than they expected. And so they wanted help and thought maybe a systems thinking approach might be helpful. But they also wanted to build capacity in the organization. They were intrigued with this idea of a learning organization with systems thinking kind of in its core. And they also were wanting to make sure that the field, which is the people marketing and selling, and the factory, they called their software engineers, their designers, the factory. They weren't producing physical stuff, but they were producing software. They wanted them to learn how to work better together. And there were some other agendas there, which was that to begin to think together rather than depend on top management. So one of the first things I did right out of our discipline of system dynamics is figure out what was the reference mode here. What does this work need to explain? And if I was doing a simulation model, what does it need to produce? So the black line is, I mentioned this idea, time to volume. That's how much time they had expected to meet a certain volume metric that they had on their software products. And so it's an S-shaped curve. It would grow, hit the volume, and then kind of stay there. What they had discovered, and I asked for data on this, was a lot of in fact, most of their recent new product launches, shown in red, were one, not getting to forecasted in that expected time, and two, were when they finally kind of met some level, peaked, it was far below what they had forecasted. So they had two problems. One, it was taking longer, and two, they weren't getting to the goal. So if there isn't a classic system dynamics, opportunity here, wow. So that's what led me to do the following work. So I basically I didn't build a full-fledged model by any means, but I taught people some of the major concepts, feedback loops. We worked together. They launched a mapping team that I worked with, and spent some time kind of helping them map through, and basically came up with a set of stories about what was behind their time to volume issue. And it had all sorts of impacts. And one of the questions that I had going into this work at the very first workshop, where we gathered everybody together in one big room, all of the management team, and I think the top probably 70, 80 people in the organizations, I put a question to them very early on as we began this work. And the question was, How many people believe they understand what the problem is with time to volume and how to fix it? And yeah, probably 80 to 90% of the participants in the room raised their hand. And okay, I said, thank you, good. So, and then I asked, are you willing to put that aside and take this journey together to see if we maybe can learn something that might be different than what you currently think? And they all nodded, sure, sure, sure. Even at the end of 2 days, when we just began using some archetypes and some modeling, I put the question at the end of the 2 days to them again. I said, so now how many people believe they know what the problem is and how to solve it? And guess what? Only about 2 or 3 hands went up. And so for me, that was a pivotal moment when, if you can stop people in their tracks in terms of where they think things should go and actually have them enter into an inquiry, a systemic level inquiry, that's already a big shift. And if you got a model and you got all that other stuff to go with it, even better. But that was for me the pivotal moment. Lots of things emerged in this process. And as I mentioned, they ended up creating a series. This was also first, wasn't just one archetype, but there seemed to be many different stories emerging about the time to volume issue. And so we were mapping those different stories, and yeah, you can fit them together, but they're all just shining a light on different aspects. So here are the headlines from some of the stories, which for me are telling. How the field isolates the factory, that the field's perception of product quality drives time to volume, that divided we fail, planning by panic. You can see, you can imagine just with those headlines, there's a lot of stuff going on here. And so here's one example of one of the stories that emerged, which is how the field isolates the factory, which turned out to be a shifting the burden. So for those of you who remember you're shifting the burden, that, you know, the inner loop is, what do we do? What do we do quickly to get things through? So a new product would get launched, and the field, so these are the sales reps and the marketing people would say, wait a minute, this product is not going to exactly meet GE's needs. So what can we do quickly? Because they were all pretty much technical, to kind of fix this up for them so the software would be more appropriate. So that was a quick fix. The longer term one on the bottom loop here, I guess actually this is a shift. I said fixes the back. I said shifting the burden fixes the backfire. Sorry. The unintended consequence of those sort of local fixes was that the factory never heard about them. They were isolated from that, and they couldn't improve the product. And so guess what? The product from the factory was never getting any better, and field was continuously having to extemporaneously improve things locally. And so part of the consequence of that was that the field, the guys, again, who were responsible for selling and marketing this stuff, began to get really disillusioned with the product, didn't feel like it was the right fit. That's the upper outside loop there. And so new product sales dropped off, and that had longer term consequences in terms of what was happening in the factory and the people being hired and expanding so they could be more responsive. And so all sorts of implications of this. That was, for me, a simple example of how these qualitative sort of soft side of systems thinking could be very insightful, that you didn't necessarily need to build a full model to get to this learning. So that's one example. Shall I do another one, Ben, or keep going? Is this helpful?
Yeah, maybe one more.
Okay.
You planned for one more, so why not do one more?
Yeah. So one thing I forgot to mention that is another big learning for me in this process, and I think one of the innovations that I, as well as many other people, have brought to systems thinking, as on the qualitative side of the field, is the idea of mental models and the power that mental models play. And I think I looked back to who invented that term, and I think it goes back to Jay Forrester. I think, Bennett, you and I may have had a discussion about that, but the earliest mention of this idea of mental model can be attributed to Jay Forrester, that in his mind, it was we have the simulation models built into our brains, and that's how we make conclusions that may not be based on a really thorough understanding of how things are connected and how things play out. But one of the powerful elements of this work is that recognizing that there are certain biases that we all have that we bring in that guides our actions. And if you don't begin to challenge those premises, those beliefs, you're not likely to get different actions. And so here in this mentor graphics examples, a few of the telling mental models that were going on that made it hard to solve the problem. And so you can see there's some, I don't know if the pointers here, nope, okay. But some of the top ones have to do with the field and some of the bottom ones have to do with the factory. And so anyway, those naturally start to surface up when you do start modeling, when you start doing these causal loops and archetypes. I find them very powerful and very helpful. Okay, here, let's do another one, which for the South Dakota people, you're gonna love, because this is about Faulkton, South Dakota. I don't know if anybody from our South Dakota group knows about Faulkton. You've ever been to Faulkton, which is, I think, central South? Anybody familiar with the town or the county? I think it's Faulkton County, and Faulkton is the city. Anyway, this was probably 7, 8 years ago, maybe longer, probably 10 years ago. But I was doing work in South Dakota. I've done a lot in South Dakota in addition to doing some courses there. But this is a place where I had fun with doing both causal diagrams and stocks and flows without running a model, but to help a community. So I like the idea that a map is worth 1,000 words. So this is a case of rural housing. So here you have Faulkton, small little town in South Dakota. And the question that they were dealing with, and I was asked to help, is what should we do that will generate healthy and vibrant housing in our small rural community? Now, I usually like a why question, but that's okay. So we're trying to figure out, and the community was all engaged in this. They had like 80% of the entire town was engaged in this process. And back, I was about right, about 8 or 9 years ago, almost 10. Okay, so they had commissioned a housing expert to come in and do a report about their overall housing. And they produced, a 70-page report with all sorts of stuff, with 17 recommendations and, all sorts of things like there should be more ownership and private ownership, and maybe they should think about housing development. And I took this as a classic laundry list approach. So they had inventoried the housing in this little town, and they had these 17 different recommendations. And I looked at that and I said, I think there might be an opportunity for systemic view. So here's one of my favorite things. By the way, another trick in this work is use cartoons to make the points. People love cartoons. And Ben knows we use them all the time in the course, but most of you have been through the course, so you know about that. Anyway, so I thought they were exactly here. I think we're in a good shape to start making the same mistakes again. So I kind of felt like, okay. So I said, I was going to introduce the idea of stocks and flows to them. And I asked them, what does a bathtub have in common with housing? And so, I explained to them stocks and flows. And then I said, well, the same idea is true about housing stock. You got stuff that's coming in and you got stuff that's going out. And let's take a look at Faulkton's housing stock and its housing flows, because the report had fortunately identified, I think, 4 categories of housing. There was stuff that was in great shape, 154 houses at that time. There was stuff that needed some minor repairs, there were about 71 of those. there was stuff that needed significant repairs, and then there was stuff that was just junk and should probably be torn down. And they had this in the report. And I said, you know what? And that's about 27. I said, you know what? Those are not discrete. Those are connected. So I said, well, wait a minute. It should look like this, right? Those flow from one another. So sound housing without proper maintenance and support will eventually have minor problems. And minor problems, if they don't get fixed, become major problems. And major problems, if those things don't get repaired, sort of start to fall apart and become dilapidated. So the first thing I did was take the laundry list approach and the inventories and said they're connected. It's not a discontinuous system. One leads to the other, which of course started to open up all sorts of possibilities. So it turns out that more than a quarter of their housing was either in, on the right two boxes, either needing major repair or was falling apart. And I actually did a little simulation based on time to move from one category, one stock to the other, average time and all that stuff, and ran some experiments. And it looked like if they continued on that way, they would go from 28% of their total housing needing, a lot of work to 38%, almost, starting to approach half their housing, which of course would be unacceptable, would be in pretty bad shape. That got their attention. So one of the ways I used the stock, it's very simple. You can see stock and flow was, so what should we do? What would you recommend? Well, what we would recommend is what the report had recommended was, well, focus on getting new housing construction. Obvious, just pump in a lot of new housing construction and that would take care of the problem. And I said, well, that certainly would help. But what about all this other stuff over there? So it's not only you need to increase the inflow, new housing, but you needed to decrease the outflow as housing starts to age and needs upkeep. So you needed to not only add to the stockpile, but you needed to make sure that stuff didn't move to the right. And when it did move to the right, you actually needed to get rid of it faster, which they weren't. They had a lot of stuff sitting around. The town was, for many reasons, unwilling or unable to pull it down because it was in private ownership, all sorts of stuff. So that worked for me. You could feel the room like, wow, you can feel people's thinking shifted in terms of how they thought about what they were going to do about their housing problem, which was not only to do the standard stuff, but to consider other stuff, which they did. One of the things that was very satisfying is in that project, and it was basically, it was a couple of day workshop, some work I did and then came back to them. So it wasn't a big deal, a project, but there was someone from, I guess, a state newspaper called Dakota Fire, which focuses on rural revival. And there's a reporter there who was taking note of all this and published an article. And here is the main graphic in the article, which was bathtubs hooked together, and it represented the stock and flow diagrams and something that people could probably actually follow. And I just loved it, and I thought that was really a telling moment. Of course, the real system, if you wanted to go further, was things, if you actually address the repair issues, you recycle stuff and it gets much more complicated, and then you've got aging. So there's a lot more, but in this case, all that was needed was a simple stock and flow model that revealed how all the stuff that they had in that report, kind of the laundry list on the left, could be translated in something that would be far more comprehensive and systemic on the right. So I'll stop talking there because I've talked a lot.
Yeah, thanks, Mike. Those are both really cool applications to see, both the qualitative and the sort of archetype versus stock flow, but generating insight from both when used effectively. I had one more question, but to get to some more maybe open Q&A, I'm going to maybe skip something I was going to ask you about on education.
Yeah.
But just on a more personal note, something that not a lot of folks in the systems world may know is that you're also a world-class photographer and have been around the world and have showcased your photography. And so I asked for our audience if you would mind sharing some of your photography and maybe where you're going next with that.
Well, thank you, Ben. And I won't spend a lot of time on this. And whenever I get a chance to show my pictures, absolutely, because my family is pretty sick of seeing them. So who else am I going to show them to? So here's another model stuff. Let me skip through this because I put all the stuff at the back. This was a work I did, if we want to come back to how to use systems thinking in dealing with homelessness, and an interesting work that we did up in Calhoun County, Battle Creek, Michigan. And one of the things I think I mentioned, and so here's some of my favorite cartoons, but what I find really works well in this work, whether you're building a quantitative model or you're doing just stock and flows or you're working with archetypes, is the use of humor. There's just nothing better to make the points about structure drives behavior. So I just happen to have a few images here that I wanted to share with. This is up here in New England. Most of these are New England. I have been down to where Ben lives, actually his home, or near your home down in southern Texas, McAllen and elsewhere, just below Kingsville. And there's fabulous bird life there, and I've been there many times shooting bird life. But this is mainly New England. This is a black-winged red-winged blackbird. Thank you. Got it. Okay. This is a little blue heron catching a tadpole. These are all actually within the last few weeks. This is a green heron about to consume a frog. How do you think that frog is feeling right about then? I love these guys. These are young punks, green herons. This is a black crowned night heron, literally in the center of a town, Winchester, Massachusetts. This is a bridge, there's a river down in the middle of town, and there's a Chinese restaurant, and there's, ice cream place all around here, and this is all going on. Crazy. This is actually from Conowingo Dam. This is again a commercial spot, but there's eagles that come there and do fishing for fish that are coming through the dam that all get stunned when they're going through the dam. So they're off guard, and these eagles just go right after them. This is one eagle dropping the fish, and the other eagle, who's a juvenile, just about ready to grab it. Here's South Texas, roadrunner with a mouse. Also South Texas, a Harris hawk, 2 Harris hawks. And just so you know, I don't only do wildlife. This is the San Juan's wildflowers. This is done in the summer. So there you go.
Excellent. Those are so cool, Mike. Thanks for sharing those. So at this time, we should have at least a few minutes of open Q&A, and I have some in my back pocket if it didn't generate questions from folks, but I imagine there's some thoughts. So the floor is open, questions or things for Mike. Go ahead.
Yeah, please do. Sorry for talking so much here.
So I'm just gonna shoot one off. Mike, I work with the dairy industry right now on a big systems model, and that cartoon with the dominoes has opened up the eyes of more. They see that and they say, what you're saying now makes sense. And so I just can't emphasize enough what you put on your PowerPoint of the power of cartoons.
Yep.
And I was wondering, could you elaborate on this in your notes and during your lectureship? You really emphasize the power of creating an open atmosphere for shared learning from the top to the bottom. I think it might be interesting for the kind of newer people to hear about that, to really get those insights from everyone.
Yeah, Hector, can you be a little more specific in terms of that? Because I could go many different directions with that one. So what for
I
you
guess
is- Yep.
specifically when you approach the group in Faulkton, or how do you approach a group in order to enable them in your sessions to communicate what they're really thinking about the system in a way that is not confrontational? Because I know that's a big part to elicit those variables.
Yeah. So yeah, my style is to, maximize participation and have people do a lot of their own thinking and, do group work, small groups, small teams, talking together, thinking together, reporting it out to the larger group and kind of rolling it all up. That's the style, you saw it, you see it in my teaching, but I also do with the client. What you experienced in the classroom in terms of how things go is very similar to what I do with any client. It might be, with the clients, I'm not going to teach them S's and O's and get into the details of stuff anywhere like that. But having them introducing a framework, having them use the framework, having them report out, kind of seeing what emerges as common themes, giving and getting feedback from each other. Yes, that's very much part of the process. And I kind of goes all the way back to when I realized that getting into the nitty gritty of detailed model building, I was losing the impact, which comes from people having those kind of insights and aha moments. And yes, you can get it from the sim, and for sure. And it's great to have the model behind you to validate that people are not being misled. But that it's very important that people are very much engaged in the process and are not just the recipient. So here, I built this model for you, and here's where things are going to go. I could have done that with Faulkton. I said, yeah, I built the model, it's talking low, and you're in trouble, guys, because another 10, 20 years, you're going to have 40% of your stock is going to be crap. There's something about, well, let's build this together. Let's think this through together. And what do you think? And yeah, so great question. Thank you, Hector.
Yeah, thank you, Mike. That impact of it's really important to keep in mind as, for us practitioners who are just starting. So thank you.
Yeah. The more visible and transparent, the better. Not always easy to do that, but the more you can do that, the better. That's why I love the cartoons, by the way, because that can connect right away to people. So, I get what you're talking. You're talking about fixes that backfire. That's what you mean. Yeah.
I've got a question for you, Michael. Can everyone hear me?
Yes.
Yeah. Okay. My question is interesting to see the focus on the qualitative side of things and the mental modeling, and then the interaction with, so to speak, the stakeholders. I think this qualitative side of the system dynamic has often been criticized by even people in the system dynamic community, and sometimes even more difficult to publish work that have focused on the qualitative side of things. So I don't know what your take on that. What advice would you give to people who are always working with this kind of mindset?
So are you saying that the quantitative side seems to have taken on even more?
Yes.
So really interesting. So let me give you a little history. So Jay Forrester didn't, he was doing quantitative model, but never paid attention to whether the, historic data, particularly matched it or not, or did any, regression analysis or validation. In fact, he didn't even like the notion of validation. What he wanted is that it met, and forget the word that he used to use, that it was a fair representation. We don't know if it's valid, but it's a fair representation. But since then, the field, and I would say largely led by John Sterman, who's the head of the system dynamics department at MIT, and key to the System Dynamics Society, which we're all part of, I think has recognize that if system dynamics is going to be academically acceptable, stay in the same ranks as economics and sociology, and people are going to have to be far more rigorous about their models and model testing and take on directly the issue of validation. So I think for sure, I have seen, an experience, I think very similarly, it's gotten much more and more technical in terms of making sure those things are done, and for good reason. But the other side of that is the qualitative side now has suffered a bit. It's harder to get papers published, I believe, even though there keeps being a push that we need to do this, and we recognize that's very valid. But right now there is that dilemma, that separation. So I don't know, and Ben certainly kind of straddles both. Maybe you can speak to where things are now, but there, at the same time that we're being much more rigorous about model validation, using statistical methods, there's also been a big call and interest in the qualitative side. I'm thinking Ben, George Richardson and other people trying to kind of get hands around, well, okay, if we're going to go qualitative and there is some valid arguments for its value and impact, and I'll be the first to support that, how do we validate these things? How do we know it's not just a bunch of crap? What are the standards to use for qualitative kinds of models? And take it that way. So hopefully I tried to address the question. Let me know if that's.
May I?
Yeah. Go ahead.
Thanks, Mike, for the fantastic sharing of parts of your life. My question is very similar to the Julius one. I think we are fantastic in the qualitative analysis of the system. And we show very high control of the system in qualitative modeling. But then when we go to the quantitative modeling, it's like we lose contact with the previous phases or with the qualitative, with the relevance of the loops. So it's like we focus more on the modeling, on the mathematical part, and so I feel that this link is missing. It's like close the loop. So go back to the loops after the qualitative model. What do you think about that?
Well, I couldn't agree more. So it's really interesting. So I think my book, Study Notes, that I talked about was the first place where the notion of causal loop diagrams and, using S's and O's, I think we're using pluses and O's, kind of making that very explicit, because Jay had done some of that in his early books, but not a lot. And I took it further in that first book. And Jay had always thought about those, those sort of qualitative loops, causal loops, as something you did after you did your modeling, your system dynamics modeling, as a way to explain the model. And what I did was reverse the process, and that's kind of what happens now a lot, which is to start modeling, which is to create the loops and try to figure out what's reinforcing and balancing and plus or minus, positive or negative, all that stuff as a practice to begin before you enter into the quantitative side. So it's interesting that you're saying, well, we actually, after you're doing the quantitative side, we really need to come back to the qualitative side. And I couldn't agree more.
Yeah.
Couldn't agree more. But just interesting how that's shifted. And it's gotten lost. Yes. So yeah, totally agree. What people are going to remember, what's going to have impact is the story or stories that come out of this. They're not going to remember all the stock and flow stuff. They're going to remember, what are the big lessons? What are the interesting stories that come out? And that ultimately means probably more qualitative than quantitative. So, a lot has to do with who's the audience for this. the academic audience is going to have a different level of criteria than the client, the public audience. So that's another issue there, is what works in one may not work as well in the other.
Great. We are right up on the next hour, and if you have to go, we certainly understand and appreciate that. Mike, if there's any lingering questions, you mind hanging out a couple more minutes if there's.
Sure. Yeah, I got a few more minutes if there's any.
Yeah, I did have one that I kind of had shared with you, but I think you kind of in part answered it, because I like a lot of our group are in higher education, and always thinking about better ways to engage with the students and make them more impactful and whatnot. And I think your comment there at the end about closing the loop on the qualitative part and what are people remember? Well, they'll remember the story. And so we do a lot, what we do in the classroom a lot of times is the mathematics and the data analysis and all of that. But, does that really improve our storytelling and our narrative framework and all that to make us better communicators?
Yeah. Great.
You did mention something, Mike, in your remarks, and I'm pretty sure I've found the reference you're talking about to Forrester and the first use of mental models in there. I don't have it off the top of my head, but I know recently, because of some of the things that we've been talking about, have located that. And while I was locating that, and preparing for teaching what I'm doing right now, I did a little search online and some systems resources, and I couldn't find a good answer for this, but you brought it up a few minutes ago in terms of the origin and sort of the genesis of the iceberg diagram or the iceberg model. Yeah. And so I started looking around, where was the genesis and where did that iceberg, events, trends, and structure and get below the surface and all that. And so what was the first use of that? Where did that, originate?
Wow. Well, interesting, Ben, because I'll have to send it to you. You'll love it. I didn't even think about including you in this, but there's someone who's trying, Beth Swain, I think, who's part of the Climate Interactive. She's, I think, a leading researcher or scientist there. She's publishing a book, and she asked, because she's using the iceberg, and asked, so who do I attribute the iceberg to? And there's been this wonderful discussion, international discussion, including Peter Senge and myself, about where the origins are. And so I'll send you all that. But as far as the current story that it seems to emerge is that I think pretty much started with Peter Senge back in the 70s, late 60s, as part of the beer game debrief, started using that structure, not the diagram so much, but the kind of different levels of thinking, and then I picked it up and it sort of created diagrams for it, put it, took it and published it, so to speak. But apparently there's all sorts of other threads in this. But that seems to be the closest we get to the origin story. And Peter couldn't really say where I couldn't remember where he had kind of gotten that idea. But I think it's safe to say that I think Peter was, it came out as a way to debrief, because back in the good old days before the debriefs that we see now, people would play the game. And there would be, they'd see the results on the wall, and there wasn't a lot of explanation and debriefing it. When it was at MIT, and it was Peter and many of us later that started to say, well, we need to take it further than, wow, this is overwhelming, and how did this happen? And actually start to have a way of debriefing that. And so I think that necessitated coming up with let's think about what was happening at the point in time, what's been happening over time, and why that might be happening. And that gave rise to the iceberg. Great question, though. I'll send you that.
Sure.
Thread.
All right. Any other provoking
Ben,
questions.
do you have
Sure, Alberto. Yeah, sure. Go ahead.
just one challenging question? I would like to have your opinion. The world is going through big data analysis, machine learning, deep learning, which are actually we are coming back to the empirical relationship without causality, without rational approach. So is the system dynamic helpful, or because I feel that people like this approach, but it's totally out of rationality. So
Yeah.
Just a comment on this.
Wow. Okay. So if I understand a great question, I think I understand the question, which is, wow, we got all this, machine intelligence and artificial intelligence. You could take huge data and start coming out with all sorts of interesting connections or conclusions. And without sort of understanding quite how those connections are being made. What's the rationale? What's the logic? Is that the right question? Yeah. So pretty counter to the deterministic view of the world that we as system dynamics have, which is, things don't just happen sort of for no reason. They happen for good reason. And, the job and the challenge is how things are connected. And so, yeah, now we have the capability of not worrying about how things are connected, but just saying they're connected. There's some correlation. Okay. That might be true now, but is that going to be always true? And is it, yeah. So, yeah, I think it's for me, my instinct would say it's in the opposite direction to what we do. But I'd be interested what other people think on that one.
Yeah, if I could throw a tangent or a parallel or whatever, some kind of line of thought in there.
Yeah, sure.
Would be Jay Forrester's diagram on the value of information. And at the top of his diagram is this large pool of mental models. Below that, some fraction of that is the written database and sort of the narrative or the story database. And then down below that is a much smaller piece of the quantitative numerical data. And what Forrester, my understanding would be, is that the richer, more insightful, more useful database is the mental database, which is much richer there. And it's orders of magnitude larger than what we can quantify.
Well, I'd forgotten about that diagram. Wow. Okay. Whoa. Yeah. All makes sense.
Andreas, you have your hand up, please.
Yeah, I just want to comment on Alberto's question about the big data, because I've been struggling with that same sort of issue in my head. I'm working a lot with engineers and a lot with big data scientists, and well, they are all for the sort of data-driven approach. But then I read some work by a professor named Scott Page at University of Michigan, I think, and he puts it quite well. He's written a book called The Model Thinker, where he actually writes a bit about system dynamics as well, but about many different types of modeling and many different types of models. And he asks the question if the sort of era of models is over now that we have in machine learning and big data and AI. But his sort of conclusion is that no, it's definitely not over, because the reason that you need models, or that models are useful, is that with big data, you can do marginal improvements to systems. You can find sort of from the spot where you are, that can direct you to the nearest local optima, but only within the data range that of the data set that you have. It might be that local optima there might be a global optimum that you won't find if you only sort of follow the big data. And that's where the models become useful, because they allow you to explore sort of the bigger field or the bigger landscape to find the global optimum in the system.
Yeah.
So I can really recommend some of his papers. Scott Page is his name.
Yeah, and very true. Yes, yes. You know, Jay always stood for, and our work is about, you know, all of the work, whether quantitative, qualitative, is improving our mental models, improving our understanding, because ultimately that's what's going to drive our decision making. And if you think about big data, how does it improve our minds, our mental models? It's a little mysterious. It doesn't. It just says, well, now let's rely on what's being popped out by the algorithms. And so as soon as the situation changes, or, you know, how are we learning from that? And we may not be. I had never thought about that, but yeah. And to your point, it could be very local as opposed to more global. Yep. Very nice.
All right, any other thoughts or questions before we wrap up this month's meeting?
So just to add really quickly that there are hybrid models that are trying to be developed within the National Animal Nutrition Program for this systems like mechanistic structure, and then using the data to inform and drive those things. But then I'm a bit in the precision ag world that I'm in for range cattle, beef cattle in Western South Dakota. There's a ton of unintended consequences arising even as we're implementing precision technology that just supports the tremendous need for systems models to even implement the AI and machine learning. So just two thoughts.
Yeah.
Yeah. And I just wanted to say thank you, Mike. This has been foundational, and what a opportunity and a treat for us to hear from you.
Well, thank you. You guys are kind to
Yeah.
have me participate in this, and continue the great and important work in the work you guys do in food and agriculture, because you know, that's I think has been, it's, you know, it's relatively newcomer to the system dynamics world, and I think an important one, and I've so come to appreciate it in the years of work with the King Ranch. So keep up the good work, guys.